Hello, this is Kid. Latest paper 2020 November. This was the last IB past paper before the new AAAI syllabus. So well, let's get to it. Question 1. So they want F1. Now this is paper 2, so you can use a GDC. So technically you can plug in your GDC, but I hope you don't need it. 50 over 1 is 50, so you add them up 52. But for part B, you will definitely need it. You do not want to even try. I mean, in some case, if the equation is super obvious and easy, you should try. But for this one, as a matter of fact, this is not something you can solve by hand. So you'll have to use a GDC to help you. So you're going to graph it. Now, I personally do not like to use NSolve or Solver. The reason is NSolve and Solver only give you one answer. But sometimes the equation might have more than one answer, then it won't be able to give you that. This time there is only one. Calculate zeros. Negative 4.05 for 3 sig fig. That's it. A, there is a minimum. So, okay, find the minimum. Calculate minimum there. They want coordinates, so both x and y. 2.77, 28.5. Okay, super easy for first question, which makes sense. Second question, a regression line questions. Again, your calculator is probably different from mine, so make sure you know how to use yours to find regression line. I think regression line would definitely come up in the exam of the first syllabus. So ax plus b, so by the calculator my a is negative 9.85, that's the gradient of the regression line, b the y-intercept of the regression line, 2 to 1. Correlation coefficient is the R, negative 0.981. Now, so in the old syllabus, regression line was extremely straightforward. In the new syllabus, they actually add the difference between x on y and y on x. So go to my solution of the specimen paper for a little bit more details, or get my course on Udemy for extreme details. Use the regression line to predict when the temperature is 12, so you simply plug 12 into the regression line. So A is negative 9.85, 12 for T, plus 2 to 1. Okay? So you use your regression line to predict. So, and by the way, 12 is within the range of the data. The range of the data is from 18 to 8. So this is called interpolation. Interpolation are considered reliable prediction, while if it's outside, it will be unreliable. Nice and easy. Okay, a probability distribution question. Well, there's only two things you need to know for a table like this for distribution. The first thing you need to know is for part A, the total probability must be 1. So you add up the probability. You should get 1. Okay. Now the interesting thing for this question is for the 4p squared and the minus 4p squared would cancel out. So p plus q plus 0.7 equal to 1. You can minus the 0.7, 0.3. The second thing you need to know for a probability distribution, how you find the expectation. Expectation is the value of x times the probability plus the same, plus the same, plus the same. Okay, so 0 times q plus 1 times 4p squared plus 2 times p plus 3 times that. I mean, that's the expectation. So that's 0 plus 4p squared plus 2p plus 3 times 0.7, 2.1 minus 3 times 4. Simplify a bit, 4p squared minus 12p squared minus 8p squared plus 2p plus 21. The question is, you want to find the value of p for the expectation to be greatest. So you're looking for the the maximum. So we will obviously rely on the calculator to do this. Now technically this is a quadratic. So theoretically you could find the maximum or minimum by completing the square. But paper 2, so let's say we won't do that. So find the maximum. The maximum occur when x is 0.125. Now for BI, they ask for p is the x, therefore it's maximum when p is 0.125. For II, they actually ask for the value will be the y value, so it's 2.225. Nice and easy. So far so good. Next, a composite function. So f circle g, remember, means f bracket gx, which means you put g into f. So you put g into the x of f, so it's 4 minus ln(x) cubed. Then you want to solve the equation of this equal to x. I mean, for paper 2, whenever you're solving equation, you should really consider doing a graph, especially this. When you have a log equal to x, there's almost no way to do it by hand. So want a bracket ln x to the power of 3 equal, oh no, I can't type equal. I will make another function called x and look for the intersection. I can already see it. So calculate intersection. So the intercept when x is 2.85. Okay. Now BII is actually tricky. Okay, well, there's a hands way and otherwise way. The otherwise ways is okay, not too hard. But if you're aiming for 7, maybe you should try the hands way. How can you use BI to do BII? Pause the video now. Answer will be coming. 3, 2, 1. Maybe I should do the easy way first. Easy way is you find the inverse of f first. So to find the inverse of f, you change fx to y, swap x and y, and then you make the new y the subject. So rearrange, get rid of the negative. So it becomes negative x minus 4. Maybe I write a bit more steps. This is SL after all, so it's minus x plus 4. Minus x plus 4 is the same as 4 minus x. And you cube root that, so y is the cube root of 4 minus x. So that's f inverse. So the question want G2a to equal to that inverse 2a. So G2A would be ln2A equal to the inverse but plug in 2A. Okay, at this point it should be obvious. You can again graph this. But I won't do that way. Remember, there's a fast way. The fast way is the following. You are aiming for 7. You should try to learn this way. Now the question is, how is this related to the previous step? The answer is this. Remember, for an equation, you can always do the same thing on both sides. If you do the same thing on both sides, it is still the same, right? It's an equation. So it happens that you can f both sides. You can apply the function f on both sides. Okay? Now, what would the left-hand side become? F bracket G2A, that's the same as F circle G. Similarly, this is F circle F inverse 2A. Now, if you know the definition of inverse function, you will know that F inverse x is just x. And similarly, even the other way around is the same. So the upshot is basically the function and its inverse would cancel each other out. So it's like they cancel each other out. So whenever they touch, if you have x, you will only have x left. Okay, so that's basically the definition of an inverse function. So this f circle f inverse will be gone. So it become f circle g 2a equal to 2a. Okay. Now then you should realize that's exactly the equation we solved in BI. And the value is 2.85. So we know 2a should be 2.85. And so a is half of the answer we got in the previous part. That's the hands way. Okay. Now this definition of inverse has been tested have been coming up quite often lately, so you should really know it. Next, and binomial expansion question. Usually I would do the general term. Now the general term is actually in the formal booklet. If you go to binomial expansion, they write a bunch of stuff, and then in the middle they will write the following. They would say NCR a to the power of n minus r b to the power of r. Okay, that's the general term, and that's pretty much the only thing that's useful. So we know n is the power of your expansion. R is just r, we'll deal with that later. A is the first thing in the expansion. N is r. B is the second thing with the expansion, except if there is a negative, the negative go to B as well. Now your job is to find out such that this whole term give you x to the power of 6. Okay. Usually I do trial and error. So R could range from 0 to 9 because the power is 9, depends on the power. So just plug in one by one until the power come out to be 6. Now I think I should first show you that for example 6 is not the answer. For example, R is not 6. Now that's because if you try R to be 6, then here is 9 minus 6, so it's 3. So you actually have 3x squared to the power of 3, and then this would be power of 6 because you were trying R to be 6. Then this would give x to the power of 6. because a to the power of m to the power of n is a to the power of mn times, okay, negative k to the power of 6 over x to the power of 6. But then when you multiply, the x to the power of 6 and the x to the power of 6 would cancel out. So when r equal to 6, it actually gives you the constant term. Okay. So first of all, r is not 6. Okay. Now pause the video, give this problem a try. Try to find the correct r. Okay, the correct r is actually 4. I think. Now you don't need to show your working, okay? You only need to write down the correct r. We don't care about the wrong ones. So you can do it in a rough worksheet. So let me show you why is it 4 first. So 9 minus 4 is 5. Then here you have x to the power of 10 because you multiply the power. And here you have over x to the power of 4. So x to the power of 10 times 1 over x to the power of 4 would give you x to the power of 6. Okay, so that's why r is 4. 4 works. If you try an error, you basically, well, just try until you get it. 9C4. That would take a calculator. So 9C4. Learn to use a calculator to find these things. This is 3 to the power of 5. 2, 4, 3 times x to the power of 10. And then here, negative to the power of 4. 4 is even, so become positive. Then k to the power of 4 over x to the power of 4. Okay, so these obviously cancel to be x to the power of 6. Now the question is that the coefficient for x to the power of 6 is 6048. Coefficient means the x doesn't count. The x doesn't count. Therefore 126 times 243 times k to the power of 4 equals to 60, what again? 48. So it should be obvious, you divide. And then take the fourth root. Well, the fourth root is the same as the power 1 over 4. So the answer is 2 over 3. Okay. Yeah, this question is not easy. It's already getting hard, only the 5th question. This paper is not easy at all, by the way. Common ratio. So geometric sequence, they give you the first term, give you the second term. So it should be obvious. Common ratio is you take any term and divide by the previous term. So it's 1 over a squared minus 3a over a. Now be careful, you cannot cancel this a like this because there's a minus in the middle. The correct way to cancel is you first factor out the a from the top. Then you can cancel. So the common ratio is a 4a minus 3. B, find the value of a for the sum to infinity of this geometric series to exist. Okay. Now the condition is actually given in the form of booklet. If you go to the sum to infinity formula, you will see that the condition is the common ratio have an absolute value less than 1. Okay, if you don't know how to read absolute value, then memorize the following. It actually means the common ratio need to be between -1 to 1. Okay, so it cannot be bigger than 1 and it cannot be smaller than -1. Therefore, you actually need a 4a minus 3 to be between -1 and 1. Now we'll solve this inequality. It's the same as solving any inequality, except whatever you do, you need to do on all three sides. So we're going to add 3 for all of them. Minus 1 add 3 is 2. 1 add 3 is 4. And the next step, we're going to multiply every side by 4. So 4 times 4 is 16. 2 times 4 is 8. Therefore, A need to be between 8 to 16 for the sum to infinity to exist. Lastly, find A when the sum to infinity is 76, so that should be obvious. Sum to infinity, there's a formula, U1 over 1 minus R. Now check your formula booklet, it should be 1 minus R. If your booklet says R minus 1, then you got the wrong version. Okay, IB at the beginning released a wrong version of formula booklet. U1 is A. It's a typo, you know, no big deal. But apparently some school distributed the wrong version. R is what we found before. You want this to equal to 76. Okay. Now by now you should notice that you can probably graph this to the GDC to solve for A. You know, graph the left, graph the right, and then find the intersection. Then you don't need to do much work. Negative, negative, positive. But it happens that you can solve this without a GDC. So that's what I would do. 1 plus 3 is 4, because I don't like using a GDC that much. You multiply this to the right. So you have to multiply 76 by 4, and then multiply 76 by 1 over 4. And then you move this to the left, 204. So A is 204 divided by 20. You should get 15.2. So if you use a GDC, make sure you get the same answer. One more before we end this video. Section B would be in the next coming video. Subscribe so you won't miss it. Oh, I don't want that. Okay, yeah, this problem is a bit more complicated. Take the time to read it. Now, first they want you to find AC. Apparently it's related to theta, so that's the hint. You need to chop this angle in half, and so this is theta. And the important thing is this is a right angle triangle, so you can do right angle trigonometry, you know, the sine, cosine, tangent thing. Okay, so in case you forgot, the sine opposite to the angle is the opposite side. The side opposite to the right angle is the hypotenuse, and then the remaining side is the adjacent side. So we're looking for AC, so we'll use opposite, and we know the adjacent, and opposite over adjacent is tangent. Therefore, if you tangent theta, you have AC over OA. But happens OA is 1, therefore AC is just tangent theta. It's a bit obvious. It's super easy to get this 1 mark. Pretty much if you say this, you get the 1 mark. Okay, part B is actually quite complicated. If you're looking for a 7, you might want to pause the video to give this a try. Answer will be coming 3, 2, 1. So somehow we need to find the area of the shaded region. Alright, so here. and it will somehow equal to the area of the sector. The sector is this. Okay. Now, if you know the formula for finding area of a sector, that is not too hard. If you look in the formula booklet, the formula is half radius square. Okay. And now this formula only work when the angle is in radian, which according to the question it is because of this. Okay, the question used pi, that automatically imply the question is in radian. So the area of the sector would be half times the angle here. The angle here is 2 theta, so 2 theta times the radius square. Radius is 1 square. So 1 square is 1, 2 and 2 cancel out. Turn out the sectors simply have area theta. Okay, what about the shaded area? How do we find the area of the shaded region? Well, obviously part A should be useful. And the answer is this. If you cut, again, this triangle, cut this in half to make a triangle, well, we know how to find the area of a triangle. Okay, now especially this is a right angle. When this is a right angle, that means you can use AC as your base, and then this 1 would be the height. So the area of that triangle is AC times 1 base times height divided by 2. But that would only be half of that. So the whole thing, you need to times 2. Well, but you only want the area of the shaded region. So after you found the whole thing, you want to minus the sector. Well, just by coincidence, we actually know the area of the sector is theta, so you minus theta. The 2 and 2 again cancel out. AC turn out to be tangent theta, so it's tangent theta times 1 minus theta. This is the area of the shaded region. And according to the question, it would equal to the area of the sector. So the equal. Okay. The question is find theta. So you want tangent theta minus theta equals theta. So tangent theta equal to theta. Again, this is not something you can solve by hand. Oops, where's my calculator? So we'll go to GDC. Now for this, make sure your GDC is in radian, otherwise it'll be all wrong. Okay. So the first function is tangent theta. This is 2 theta. If we draw it, now theta is only in 0 to the power of 2, so you may want to change your axis to that 0 pi over 2, and then go again. So there is an intersection. We find the intersection. Theta is 1.17 3 sig figs. Okay, so we'll end this video here. I'll see you in section B.